So we just took one of the example of the rubidium. Same way we can take any isotope example and we can find out the relative atomic mass. Okay. So now
Miss,
the question, yes. Any question?
so
Hmm.
they will give us the isotope.
Hmm.
Okay.
They will give you the isotope, they will give you the abundance, means the percentage, they will give you the mass number, then you can find relative atomic mass by using the formula. Yes, Wafia.
Yes. Have we skipped one of the notes why isotopes share properties?
Which one?
Have we skipped why isotopes share properties? The second page.
We did not skip. We did this. They have the same chemical properties and they have the different physical properties. This is done. Okay. Okay. Now this question can come in another way. This is the simple straight question and the exam will never ask you the straight question to find the relative atomic mass. Maybe they can just change the question structure and ask you. How? Let's take an example. They can ask you that rubidium has two isotopes. Mass number of first isotope is 85 and the mass percentage is 72. Second isotope has the percentage 28, but the mass number 87 is not given. Find this. Getting the point? They are giving you now the information relative atomic mass will be given. Relative atomic mass will be given to you. Mass number one.
Finding X. It's like finding X.
We are finding X. So basically, we have the relative atomic mass here, but we don't have this 87 number here. So let's consider this 87 as X. Can we find this by rearranging?
We will rearrange the formula.
Yes, Mama. Rearrange the formula. So let me write here what I'm trying to say. Let's say in the exam, it is given that the relative atomic mass is 85.6, which is equal to 72 times 85.
From the noise.
Who has the noise? Let me mute. Okay. So see, we have relative atomic mass given 85.6. We have the mass number of first isotope 85 given. Its percentage 72 given, right? We have percentage abundance of second isotope 28 given. We don't know its mass number X. We have to find this X. Divided by 100, same formula. In place of relative atomic mass, you will write the number, and in place of this, just write an X and do the same calculation. Rearrange it. Try to solve this. This 100 will go on the other side and multiply. Give me the answer. Solve it. 85.6 multiplied by 100 will be equal to, do the calculator, use the calculator, 72 times 85.
Miss, will they give us the calculator in our chemistry exam?
You
For
will be
Cambridge and
using the
Edexcel?
calculator. Yes, you can take the calculator with you and you can use it. Okay. Now open the calculator, any of the student, and tell me 72 times 85, how much?
8,506.
8,506 plus 28x. Okay. This will just multiply. Okay.
8,560.
Right. 8,560 is equal to 8,506 as you said plus 28x. Now this number is adding here. This number will go on the other side and subtract. So
72 times 85 is not 8,506.
Who said this?
It's 6,120.
6,120. So calculation very carefully we have to do. So this will go on the other side and subtract, which is equal to 28x. After that, subtract it. Tell me the answer quick.
2440
is equal to 28x. 28 will go on the other side and
Divide.
Divide. So divide it.
Divide on both sides.
Yeah. Divide on both sides. So then it will go on other side. So yeah. 2440 by 28.
The answer is
87.1.
87.1.
Right. 87.1. Very close answer that you got, just like the one which was already given to you. 87.1 is basically 87. We got this answer. Okay. So they can make one of the number missing and give you the relative atomic mass. Then you can just rearrange the formula and find the missing number. Or maybe they can give you this table and ask you to find the relative atomic mass. Both ways the
Miss,
question can come.
Miss,
Yes.
they can ask, they cannot give us, like maybe you said now about the mass number, they just give us 1x. So maybe, Miss, can it be percentage abundance maybe? We can do it for the
Yes,
same?
it is possible but that they are going to remove one of the percentage abundance. But let me give you a small trick here. If they are missing one of the percentage, then there is no need to do the calculation.
Then
Why?
we will minus the first percentage with 100. Then to
Very
find the
good.
answer.
Minus the 100.
Yes, very good. Because percentage of both isotopes together should be 100,
Yes.
right? If one of them is missing, just 100 minus 72 will give you 28. 100 minus 28 will give you 72. So that thing you can just do by subtracting from 100. No need to do
So,
this
Miss,
calculation for the percentage abundance.
so just
Okay.
subtract by 100 the full percentage and we get the answer.
Yes, you will get the answer.
Okay.
You can even use this formula. You will get the same answer, but why to waste the time? Just subtract from 100 and get the second percentage abundance, because both together are 100. If one is missing, subtract from 100.
So, Miss, if only one isotope is given, we can find the other one ourselves, right?
Yeah, if only one percentage is given, we can find the percentage of other by subtracting. If one mass number is given, we can find the other one by this formula. Okay. Okay, now everything is clear so far? Any question?
No, Miss.
No, Miss.
Okay.
Yeah, Miss, could you re-explain the points you just said by how we can find other isotopes using mass number and abundance?
Okay, see, for the percentage abundance, if one is missing, then you can just subtract the other abundance from 100. Okay, let's say this 28 is not given here. So 100 minus 72 will give you 28. That is the isotope, the second isotope abundance. Okay, so if 72 is not given, then 100 minus 28 will give you the second one. So just subtract the percentage from 100 will give you the abundance of second isotope. But in case of the mass number, we cannot subtract. We have to do the calculation to get the mass number.
So, Miss, if there is no second isotope, first we need to find the percentage abundance, then we need to find the mass number.
Then we need to find the mass number, right? Yes. Then these both steps can come, but it will not be common in IGCSE. But yes, in your grade 11, this question is also common. They're not giving even the percentage of second, not giving the mass number. So percentage you can find by subtracting, and then mass number you can find by this calculation.
Miss, what if, Miss, there's two isotopes, but they want us to find the third one? How should we do that?
No, no, no.
Or
They will
there's
not.
no...
If you have the two isotopes, they are asking you to find the third one.
To be
Yeah.
the same thing.
Same thing, same thing. Abundance of 3 will be given. Two mass numbers are given. Third you want to find. Use the same formula. Isotope 1 percentage mass of the first, then the second, then the third. Here, let's say the
Miss,
mass
what
of
if...
the third is not given. Consider it as an X.
Miss, what if
Okay.
they didn't give us the percentage abundance, Miss, of the third one?
Then let's say, then the first abundance, second, third together is 100. Let's say they are telling you that this isotope is 50%, this is 20%, third is not given. So total should be 100. So it means this is 30.
30%.
Because 20, 50, 20, 30 is 100. So isotope percentage you can easily get, even if there are 3, 4, 5 isotopes.
Okay, Miss.
Okay. And mass you can find by formula, consider it as an X. And then just do the calculation. Okay. So as many isotopes we have, we can use the same method. Okay. Now, there is one thing here which is very important and you can confuse. Some of the students can confuse in the exam and take
Excuse me,
them
miss.
wrong. Is
Miss, how
mass
you got
number...
30?
Yes, Amreen.
How
How
you
I
got
got
30?
30? See, first one is 50, second one is 20. So 100 minus 50 and 20. That is 30. Okay. We are subtracting
Okay, miss,
these two
thank
now
you.
from the 100 and it will give us the 30 answer. Okay, no problem. Okay. Okay. Is the mass number and relative atomic mass the same thing? Any idea? Who can tell me this? Mass number and relative atomic mass, are these two the
No,
same thing?
miss.
Okay,
No.
tell me the explanation as well.
Can I tell
First,
the difference?
Miss?
Can I tell the difference?
they are different. Who is explaining? Raise your hand, I will ask. Who know the answer for this? Mariam Mahmood. Yes, Mariam.
Miss, the mass number is the number of the neutrons and protons.
Hmm.
But the relative atomic mass is the mass of the atom. It is the weight of the atom. Right?
Not
It's the
exactly.
mass of the atom with the neutrons and the protons in it.
That is fine. Relative atomic mass is also the same thing basically, but there is an other difference, not in terms of proton neutron. Luna, wait. Yes, Luna, now your turn. What is your answer?
Miss, relative number, it is the mass that is compared to the carbon, something relative. So it's compared to the carbon.
Okay. Yes, Wafia.
No, miss. I think I forgot to lower my hand.
Okay. Jude.
Yes, miss. When we calculate the relative atomic mass, we consider that there are many isotopes of the element, but in the mass number, we don't consider the isotopes.
That's very good. That is basically the right answer. Mass number is number of proton, neutron. That's right. Relative atomic mass is also the same thing, comparison of the mass. But mass number is only for one isotope at a time. And relative atomic mass is basically the average of different isotopes. Okay. So relative atomic mass is the average mass of all the isotopes in the element. And this relative atomic mass in the periodic table is written as the rounded number. Mass number can be for one isotope. If we have one isotope of hydrogen, we'll say mass number is 1. The other has mass number 2. The third has mass number 3. But if we are taking their average by the above formula, then we will say it as relative atomic mass. Okay, yes, Luna.
Oh, miss, I forgot to lower my hand.
Okay, Mariam. Yes, any question?
No, miss, thank you.
Okay, so I hope this is clear as well, that basically the mass number is for one single isotope and the relative atomic mass is basically average mass of all the isotopes together. And for simplicity, we are writing the whole numbers in the periodic table, so there is no problem in calculation. Yes, Samri.
Miss, we learned that relative atomic mass was related to carbon, like 1/12 of carbon.
Yes.
Right?
Relative atomic mass is relative to carbon, but also it is the average of different isotope masses.
Okay, miss.
Okay.
Thank you.